We're going to step away from programming for a moment and do some drawing instead. So in the last video, we found out how to get a random position on the screen, and we set that equal to our destination. And we have some other location on the screen called our location. What we want to do is fly in a straight line from the location to the destination. But how do we actually do that? How much do we increase the x and y coordinates by each time through the animation loop? Currently what we're doing is we're taking the x coordinate and we're adding to it the direction times the velocity, and we're doing the same thing for the y coordinate. That's why we're moving in a diagonal line, because the x and y coordinates are changing by the same amount each time through the animation loop. So how much do they need to change by to get us from some location to some destination? Well, notice that if we take any 2 points on this line, say these represent the point after one iteration and then the location after the next iteration, so we'll call them P1 and P2. This triangle between P1 and P2, I'll make it bigger down here, say that's P1 and that's P2. And that's the triangle. That triangle has the same angle as the triangle formed by the location and the destination. So if this angle here is A, then this angle here is also A. And knowing that, we can figure out how much we need to increase the x and the y coordinates by for each iteration of the loop. So if you remember a bit of basic trigonometry, this amount here is equal to cosine A times V, where V is the hypotenuse there, how much we want to advance with each iteration of the loop. And then the y increase is sine A times V. So this update logic becomes x increasing by cosine A times V and y increasing by sine A times V. And so as long as we know what A is, we know how to update x and y with each iteration of the animation loop. And we can find out what A is because it's the angle between the location and the destination, and we know both of those things.